Good evening, students. Myself is Girish K. I welcome you all to HashLearn Studios. So, in the last class, we did the problems on determinants and matrices, and in today's class also we are going to do the same concepts, problems on matrices and determinants. So, here is the recap of the previous class. And here is the problem from the last class practice pack. Class practice pack is the one set of questions where you will be given 10 important questions from the class that has been taken on that day. So here is the problem where A is given as 6 alpha, alpha 0, alpha 6 alpha 0 0 6. That is a matrix, and they have given you determinant of A square as 36. Then what is alpha equals to? Okay, so here what you can do here is, one is you can find A square and then you can take the determinant and you can find and you can equate it to 36 and you can solve it, or you can just determinant of A square can be written as determinant of A whole square. Okay, so if you rewrite it like that, so that will give you determinant of A is equal to 6 square, right? 36. So the determinant of A will be equal to 6, and from this determinant of A, see here one side of the diagonal element, principal diagonal elements, one side is completely 0, means what happens, your determinant of A is just 6 into alpha into 6 is equal to 6. So alpha is 1 by 6. So 1 by 6 is in option A. That is your answer. Okay, so remember, if one side of the elements on the principal diagonal elements are 0, means your value of the determinant will be just you take the product of the principal diagonal elements. Okay, so that was the simple problem, and that is option A where alpha is 1 by 6. And here is the goals for today's class, and we are going to solve the problems based on the applications and determinants of matrices what we have learnt in the previous classes. Okay, so here is the problem number 1 based on the applications of determinants and matrices. You have 45 seconds. Come on, what is the option for numerical 1? You have 25 seconds. There is a matrix A and there is a value xyz is equal to 60 and 8x plus 4y plus 3z is equal to 20. Then what is A dot adjoint A? Time up. Let's see what the option is. See, you know the simple rule which I have given in the last class. A dot adjoint A is nothing but determinant of A into I. Determinant of A into I. What is determinant of A? So you take the determinant of A as, if you take the determinant of the elements x3 2 1 y4 2 2 z, you will get x into, that is yz minus 8 minus 3 into z minus 8 plus 2 into 2 minus 2y. So that will give you determinant of A is x y z minus 8x minus 3z plus 8 3s are 24 plus 4 minus 4y. That will give you determinant of a is equal to xyz minus, if you take outside, 8x plus 4y plus 3z, and that will give you plus 28 again. So determinant of a is xyz minus 8x plus 4y plus 3z is nothing but is here 20 and plus 28. So what does that will give you? So xyz is given as this is 24 plus 4, that is 28, 60 minus 20 plus 28. So determinant of a is, you know that 40 plus 40 minus 20, 40, and that is 68. So 68, there is an option, you know that a dot adjoint a is determinant of a into I, so you got the determinant of a as 68. So how you will get, once you multiply the terms inside, x yz minus 8 minus 3 z minus 8, then 2 minus 2y, that will give you 4, that will give you minus 4y minus 3z plus 24, then 28, substitute, you will get determinant of a as 68. So 68i, I is identity matrix 1 0 0 0 1 0 0 0 1. Once you multiply with 68, you will get option as 68 0 0 0 68 0 0 0 68, that is option C. Okay, so make a note of this important result, a dot adjoint is determinant of a into I. Hope all follow the steps. Let's go to the next example. Numerical number 2, you have 45 seconds. Here is the problem. There is a system of linear equations and they are asking you to find the relation between A, B and C. You are left with 25 more seconds. Ten more seconds. Time up. Okay. The system of linear equations, there are three equations where the variables are x, y and z and has a non-zero solution. Then the relation between A, B and C. If you take the coefficients of x 1, coefficient of y 2a, coefficient of z a, so 1, 3b and b, that is 1, 4c and c equated to 0. Okay, you can just simplify this, or you can take the difference and you can do the simplification. So if I just apply r1 minus r2 and r2 minus r3, what happens? This minus this, I'm going to apply r1 minus r2 and r2 minus r3, so that I can make few elements 0. This is 0, 2a minus 3b, this is a minus b, this is 0, 3b minus 4c, b minus c, this is 1, 4c and c, that equal to 0. If you multiply inside and cancel the terms, what happens? This into this will give you 2a into b is 2ab, 2a into minus e is minus 2ac, minus 3b into b, that is minus 3b square. This with this plus 3bc. Okay, this is on one side, minus 3b into a is 3ab. This with this will give you minus 3b square minus 4ac plus 4bc. That should be equal to 0. Now Make a note of these terms. What are the terms you are getting? 2ab minus 2ac minus 3b square plus 3bc minus 3ab plus 3b square plus 4 times ac minus 4bc is equal to 0. You can cancel this 3b square with the plus 3b square, and this is 2ab minus ab you will have. This is minus 2ac, this will give you plus 2ac, and 3bc with 4 will give you minus bc is equal to 0. So therefore you will have a relation ab plus bc is equal to 2 times ca. So ab plus bc is equal to 2 times ca. So if you divide throughout by ca, what happens? You will get a relation where a, b, c are in harmonic progression. So divide throughout by ca, you will get b by c. Okay, you will get the harmonic progression where a, b, c are in HP, means the reciprocals will be in AP. Hope that all followed the steps. You will get a relation where A, B and C are in HP. Is it clear? Okay. Fine then. Get ready for the next question. Here is the problem. Numerical 3 with 45 seconds. The system of equations has unique solution, then the value of lambda cannot be. So for what value of lambda the system of equations will give you an unique solution. Okay, you're left with 10 more seconds. Time up. Okay, so you know that if determinant is not equal to 0, then you have unique solution. Let us take the determinant. Coefficient of x is 2, y is minus 3 and z is 5. Then 3, 1 lambda, 1 minus 7 and 8. And you know that that should not be equal to 0 to get a unique solution. If you need any unique solution, determinant of the coefficients of x, y, z should not be equal to 0. So if you simplify, what you will get? 2 into 8 plus 7 lambda plus 3 into 24 minus lambda plus 5 into minus 21 minus 1 should not be equal to 0. Okay, so once you multiply 8 to the 16 plus 14 lambda plus 72 minus 3 lambda, that is minus 105 minus 5. That should not be equal to 0. So what does this will give you? This is 14 lambda, that is minus 3 lambda will give you 11 lambda, and this will give you 72 plus 16 is 90, and that will give you 110. Minus 3 is 11. Okay, this is 16, 72, that will give you 18, that will give you 22 here. Okay, so 22 will give you your value of lambda should not be equal to 2. So should not be equal to 2. So when lambda is 2, what happens? Determinant will become 0. Therefore the value of lambda cannot be 2. 2 is in option B. That is your answer. Okay, 72 plus 16 will give you 78 plus 10 88. Then that will give you again difference is 22. So 22 by 11 is 2. Lambda should not be equal to 2, which is present in option B. That is your answer. Okay, hope that all followed the steps. Get ready for the next problem. Numerical 4 with 45 seconds. Here is a problem. Very important problem. What is the value of A so that the system of equation has non-zero solution? They are asking you to find the value of A. You're left with 15 more seconds. Five more seconds. Time up. Okay, so let's see what are the coefficients you have for x, y and z. You have a cube, then you have a plus 1 cube, then you have a plus 2 cube, a plus 1, a plus 2, and 1 1 1 and the last row. So what you need to do always, see, whenever you have 1 1 1, try to make them 0. So if I apply, this is C1 C2, I will apply C2 minus C1 and C3 minus C1. Okay, so if I apply C2 minus C1, I will write a cube a1 as it is. If I substitute a plus 1 cube minus a cube, a plus 1 minus a will be 1, 1 minus 1 is 0. Again, if you do this minus this, you will have a plus 2 cube minus a cube. This minus this will be 2 again. This minus this is 0 again. That should be equal to 0. Now if you solve the terms, 1 into eliminate along this 1. Okay, this is 0, this is 0. You have to leave the row and column. This into this, that will give you, this into this is 2 times a plus 1 cube minus 2a cube minus will give you minus a plus 2 cube plus a cube, that is equal to 0. So what happens when you do the simplification? That will give you 2 times a plus 1 cube minus a plus 2 cube minus a cube is equal to, if you take that side, it will become plus a cube. So here you can do the substitution method. So if I substitute a is equal to 0, whether LHS is equal to RHS, you can check. You know that when a is equal to 0, LHS is not equal to RHS. After doing this step, use substitution method. Let us check for a is equal to 1. If I take a is equal to 1, left hand will not be equal to right hand side. Better a is equal to minus 1 if you take. When you take a as minus 1, this part is 0 and this part will give you 2 minus 1 is 1 cube. Again minus 1 is on left hand side, again minus 1 on left hand side. Option B satisfies. A is equal to minus 1 is the choice. When you substitute a is equal to minus 1, what happens? LHS is equal to RHS you will get, or determinant becomes 0. So the value of a should be minus 1. So after doing this step, please do the substitution method to get the final answer. Is it clear? Okay, fine then. Your next problem is a previous class contest question, and unfortunately no winner, no one have responded correctly. Here they have given you P is a given matrix 1 alpha 3 1 3 3 2 4 4 is adjoint of 3 cross 3 matrix A, and determinant of A is 4. Then what is alpha? So P is adjoint of A. So P is adjoint A. So what is determinant of P? Is determinant of adjoint A. So you know that determinant of adjoint A is determinant of A whole power n minus 1. Okay, let us find what is determinant first. So what is determinant of P here? That will give you 1 into 4 3s are 12 minus 12 0 minus alpha into 4 minus 6 is minus 2, that is 4 1s are 4 minus 3 2s are 6 plus 3 into 4 minus 6 is again minus 2. 4 minus 6 again 4 minus 3 2s are 6 minus 2. So determinant of P will give you minus minus plus 2 alpha minus 6. 2 alpha minus 6. So what is determinant of A? Determinant of adjoint A is determinant of A power n minus 1, that is 4 power 3 minus 1 is nothing but you will get 4 square is 16, that will give you 2 alpha minus 6 is equal to 16. So 2 alpha is equal to 16 plus 6, alpha is equal to 22 by 2 is equal to 11. So 11 is the right choice, which is there in option X. So make a note of this formula. Determinant of adjoint A is determinant of A to the power n minus 1. N is nothing but the order of matrix. For this problem order is 3. So 3 minus 1 is 2, 4 square is 16. You need to equate determinant of P to determinant of adjoint A. Is it clear? Yes. Fine then. Get ready for the next question. Is today's contest question. Here is the problem with 60 seconds. Let me see who is going to give the right choice first. What are the values of lambda? Minus 5 by 3 or 1, 2 by 3 or minus 3, minus 1 by 3 or 3, minus 3 or 0 0 1. Yes, Himanshu, good evening. Violet man, come on, take the contest question. You're left with 20 more seconds again. Value of lambda for which the system of equations is consistent. Yeah, it's time up, and winner will be announced only in the next class. And here is the next problem, numerical problem number 5 with 45 seconds. What is the value of K? They have given you the area of the triangle. Yes, Himanshu. Numerical 5, what is the option? Time up. Time up. You know that area of the triangle is given by half determinant the vertices, that is 2, minus 6, 1, 5, 4, 1, K, 4, 1. So area is given as 35. You can multiply it with 2 and you will have 2 minus 6, 1, 5, 4, 1, K, 4, 1. If you do the simplification, what does that will give you? This is 70. That will give you 2 into, this is 0 plus 6 into 5 minus K plus 1 into 20 minus 4K. So that is 70 is equal to 30 minus 6K plus 20 minus 4K. Or you can say it as this is 50 minus 10K. This is 70. See, you need to take two cases. One is for positive sign of area and the second one is negative sign for area. If you take this as plus 70, 50 minus 10K, you can also take minus 70, 50 minus 10K. So two values of K will get here. Once you take 70 minus 50 is 20 by 10 is K value will be minus 2, and 50 minus 120 K value will be plus 12. So you will have two values of K. K is equal to 12 and K is equal to minus 2. 12 and minus 2 is in option D. That is the choice. Okay, hope all followed the steps. Make sure you take area as positive and also negative. Solve it for plus 70 and also for minus 70 so that you will get two values of K. Is that okay? Yes. So get ready for the next numerical number 6. Here is the problem with 45 seconds. Omega is the cube roots of unity. Then what is the determinant of the terms given there? Omega is the cube root of unity. You are left with 20 more seconds. Come on, Himanshu. Time up. Time up. So let's see. You know that you can observe the terms present here and all are giving you 1 plus x plus omega square when you add. So if you apply r1 plus r2 plus r3, okay, when you add row 1 plus row 2 plus row 3, what happens? You will get 1 plus x plus omega square, 1 plus x plus omega square, 1 plus x plus omega square, and you will have omega here. You will have x plus omega square and 1 omega square, 1 and x plus omega. This is the determinant. You know that cube roots of unity means 1 plus omega square is 0. 1 plus omega square is 0. So if you use 0 here and take x outside, okay, you will be left with only 1 here. I am taking x outside and omega here and omega square here, x plus omega square here and 1 and x plus omega. Again, if you take the difference, 1 minus 1 is 0, x minus omega minus x minus omega square, that will give you omega square minus 1, this minus this is 0 again, x plus omega square minus 1 minus x minus omega, that will give you again 1 . that will give you 1 again, 1 and x plus omega. Now you should be very careful. What you need to do now, you have x here and you have 1 with the determinant of these two. So be careful, you have many terms there. If you do the simplification, x is outside. Be careful, I am going to multiply this with this. You have omega minus x omega, omega minus x omega, that will give you minus omega square. Then you will have minus x plus x square plus x omega. Then you have minus omega square plus x omega square. Then it will give you plus omega cube. Okay, this is one part. Minus, again when you multiply this into this omega square, x omega square plus, you know that omega square and omega square, omega power 4, I'll write it as just omega minus omega square minus x minus omega square and plus 1, and that is what you need to close the bracket. Now let us see what are the terms that are going to cancel here. You know that plus x omega will cancel with minus x omega, and again you will have here omega square minus omega square, that will cancel with this omega square and this omega square, and you are left with omega here and minus x here and omega cube here. Once we do the simplification, x is outside, so you know that omega and omega cube will give you minus omega square. Omega is here and this is x square, so omega minus x plus x square plus x omega square plus 1, and that is minus x omega square minus omega minus 1. So once you do the simplification, this will cancel with omega, will cancel with minus omega, minus x omega square will cancel with this fellow, plus 1 will get cancel with minus 1. So this is minus x square, this x will cancel with this is x omega cube, right? This is x omega cube, that will give you, and this is x here and this is x here, so that will get cancelled. X cube is the option, which is D. Once you do the simplification, complete simplification will give you x into x square, x cube is the option, is fourth, x cube. It's a simple problem. Make sure you substitute 1 plus omega square, omega plus omega square as 0, and do the simplification, you will get the final answer. Is it clear? Fine, then get ready for the next numerical 7. You have 45 seconds. Numerical number 7. What is the value of the determinant? Come on, you have 10 more seconds. Time up. Time up. See, when you have the problems of this type, what you can do here is, because this is, you can treat this as your left hand side and your right hand side is nothing but the 4 options you can consider. Suppose if you take a as 0, what happens to the determinant? When you take a as 0, this is 0, this is 1, 1, 1 2 1 3 3 1. Okay, once you solve this determinant, if you solve, you are taking a as 0 and solving it. This is minus 1. Okay, 1 minus 3 is minus 2. Again, if you take plus 1, this is 3 minus 6 is minus 3. That will give you 2 minus 3 is equal to minus 1. Okay, after taking the value of a as 0, solving the determinant, we are getting minus 1. So which option is giving you minus 1? That itself is the answer. This is going to give you plus 1, wrong. This is also giving you plus 1, wrong. And what about these two options? This is when you take a as 0, it won't give you. So option B is the choice. When you take a value as 0, that is going to give you minus 1. That is the right choice. You need to mark. Is it clear? Yes, this is the substitution method where you can substitute the values of variables and cross verify the left hand side and right hand side. Which matches both, that is the answer. Fine, then get ready for the next question. Numerical number 8. Here is the problem with 45 seconds. They are asking you to find the value of x, y, z, x square, xz by y square plus xy by z square. You left with 25 more seconds. Yes, come on, Himanshu, no response from your end. Numerical 8. Time up. So let us see x yz by x square, zx by y square, xy by z square. You know that these are the system of linear equations in A, B and C. So they are the linear equations in A, B, C. So if you write the coefficients of A, B, C, yes, Janvi, Violet, if you take the linear equations in the form of A, B and C, okay, so what does that is going to give you? First you rearrange them in a order A, B and C. So what is the coefficient of A here? X by y. B is y by x. And if you shift this C that side, that will be coefficient will be minus 1. Then what is the coefficient of A? Shift it here, minus 1. B is y by z. Y by z is B and C is z by y. Again shift this, A is x by z, B is minus 1 and C is z by x is equal to 0. Okay, so see, these are the system of linear equations in A, B and C. Determinant should be equal to 0. Then what happens? Once you solve this, determinant x by y into this is z cancels, y by x, that is plus z by y, then minus y by x, if you take minus z by x minus x by y, then minus 1, that is 1 minus xy by z square is equal to 0. So simplify this, what you will get? This with this will give you cancels 1. This with this will give you plus xz by y square. That with that will give you plus yz by x square. That with this will give you minus with minus plus 1. Minus 1 plus xy by z square is equal to 0. You can cancel this with this. So that you will have xy by z y square, xy by z square plus yz by x square plus xz by y square minus 1, that will give you minus 1, which is your option B. Is it clear? So what you need to do here is take the linear equations and treat a, b, c as the variables and put the coefficients of a, b, c in the determinant and equate it to 0. You will be able to get the answers. Is it clear? Hope that all follow the steps. Yeah. So here is the summary of the class. We did the problems on applications of determinants and matrices. So thanks for joining us, students. Hope you liked the class. If you are like, please do share these videos among your friends and help them. Now it's the time to CPP, that is class practice pack. So students, I have given you 10 important questions from the topics what I have discussed today. So CPP is unlocked and available for solving immediately after this class for passport holders. For non-passport holders, you need to subscribe for the CPPs to be unlocked. So please do subscribe for the passport. If you subscribe, not only you will get access to CPPs, but also you will get access to 24/7 one-to-one doubt clarification sessions, and also you will get practice questions and tests from best-selling authors, and also you will get access to all the video classes covering the toughest concepts and the problems. Okay, so please do subscribe for the passport. Thanks for joining us again. See you. Good night.